Hello everyone, welcome back from a really long break. I hope everything is going okay, that everyone is ready to continue, and just continue with what I was doing like 2 weeks ago. And also, as I said um in Discord, like during the break, I plan to continue doing the reviews so we can get like up to date because we are a little bit behind. So now let's continue doing the exercises. Now, number 47. Lena plants a tree sapling in her yard and measures its height every year. Her measurements so far are shown in the scatter plot below. Based on the scatter plot and the line of fit, which of the points will have positive residuals? Select all apply. Okay, basically, what this means, positive residual, is just that this point is higher than expected. So if this is the best like fit line, this is going to be the point, basically. Now, based on that, I'm gonna go 0.2.1, and this is actually in the line, so not really. 1, comma 4.3. Okay, I like this one. For now, this is okay. This is good. This now 2, comma 5 under the line, so no. 3.73, yes. 4.8.1, no. And 5, comma 10.2, yes. So it's going to be, okay, there's no. It's going to be, okay, 1 comma 4.3, 3 comma 7.3, and 5 comma 10.2, because those are the ones over the baseline of it. Now for 48, the Scatterplot shows the growth y in inches of the elk's antlers after X weeks. The associated residual plot is also shown in the graph. Okay, the residual is going to be X. Which statement is true? Okay, first I'm going to observe the graph. I see that the residual is X, and these are the X, and these are the observations, the points. And this is just the line of it. Now, oops. Which statement is true? The growth of an elk's antlers Y after X weeks have a strong positive correlation. The growth of an elk's like first positive correlation just means that it is positive. As we can see here, like if the line is going down, which means it is a negative line. It is decreasing over time. So for right now, I can go here and I can say this is not my answer because it's talking about positive correlation, and this is also not my answer because it's talking about positive correlation. Now, the the growth of an elk's antlers Y after X weeks have a strong negative correlation, or the growth of an elk antlers Y after X weeks have a weak negative correlation. Well, sincerely, what the meaning of a strong and weak is just that the points are like actually nearby the baseline of it, and there are not like a strong one will look something like this, and then the points will be here, here, one in the line, here, 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 basically like that. While in a weak one, the points will be all over place. For me, I think this should be a strong, like despite this point that is really outside of the range we're expecting, very far from the baseline of it. I think it has a strong negative correlation because all the other 4 points are like really close to the line, really showing the actual decreasing over time. So I will say the answer is C. 51. The table contains data regarding the number of high school graduates and the number of high school graduates enrolled in college in the United States between 2010 and 2016. Which equation best represents the set of data where X represents the number of high school graduates in millions and Y represents the number of high school graduates enrolled in college? Okay, first let's see that the X is represented by the number of high school graduates. They're like in general, not enrolled in college. So I make a note here. It's going to be X, and then the Y represents the high school graduates that actually go to college. This is going to be Y. Now, what I can see here, like by side, that there's always 1 million more of high school graduates than the high school graduates that go to college. Like approximately. The difference here is 1, this is 1.1, this is 1, this is 0.9, this is 0.9, and this is 0.9, which is like we could say that is approximately 1. So when one high school graduates go to college, like 1 million high school graduates go to college, zero graduates, like zero, wait, I'm saying it wrong. While 1 million of one high school graduates, like actually high school scholar student graduate, then zero go to college. But then that's basically the linear correlation. I don't know how to explain it. What I could say is that, for example, I can substitute the values here, and I could take 3.0 and see which of these equations actually gave me 2.0. I could say, okay, 3.0, 0.54 times 3.0 is gonna be about 1.50 something, 1.50 something plus 0.45 is actually 2, so we're good. Then here, is actually going to be also nearby. Mm. In this case, this is not a possible answer because if we put 3 and the x and then we add 0.97, we're going to get 3.97, which is not 2, so we get away with C. And then for D, is more or less same. We multiply 0.97 times 3 is going to be 2.8, something like that, approximately. I'm doing this by mind. And then we add 1, it's going to be 3.8, which is increasing and is not what we are looking for. Now, in this other case, these two were really equal, so I'm going to use the calculator. I'll go 0.54 times 3 plus 0.45, okay? 0.54 times 3 plus 0.45, I got 2.07. So it's really close, so okay, and then 0.45 times 3 plus 0.54 actually. I actually, both are actually really close, so I'm gonna take another point. 3.2 and 2.1. So we'll say 3.2 times 0.54 plus, oops, 3.2 times 0.54 plus 0.45. This 2.2 2, which is the actually what we are looking for. And what about the other? 3.2 times 0.45 plus 0.54 is 1.98, so it's not what we are looking for. Then this is not going to be our answer either because it's not giving us the point we want. And therefore, answer is part A, like option A. Now, 52. Carla believes that the more time she spends in the supermarket, the more money she spends. She records the recent purchases on the scatter plot below and determines the line best fit. Which is the following is the equation of the best fit line. Okay, first what I will do is calculate the slope. We have this point, which approximately 25 and 60. Then this point, which is 5 and 10. And using the, like in this case, we always use the best line of fit because that's what they're asking for, the equation of the line of fit. So I'm going to use these 2 points and I'm going to say, okay, 60 minus 10 for the y values over 25 minus 5. And this is going to be 50 over 20. And this is 2.5. So our slope should be around this. And so we can get out of this one, out of this one. And we have a 2.4 slope. Now, we will we would like to know with these 2 points and the slope, like with a point and the slope, we can actually get the equation and know the y-intercept. So do you remember? Yeah, you must remember this, that y minus y1 equal m x minus x1. So since now we have the slope, we can actually take 1 point and calculate the y-intercept as we have done before. So I'm going to take 5 comma 10, which is an easy point, 5 comma 10. And I say, okay, y minus 10 equal 2.4 x minus 5. Y minus 10 equal 2.4 x minus, it's going to be around 12 something. 2.4 times 5. Oh, 12. Minus 12. So I'm going to add 10 to each side. And I get y equal 2.4x minus 2. And so we could get away of C because it doesn't have a y-intercept. Or y-intercept, it says that the y-intercept is 0 and we're not looking for that. And we see that our correct answer is D. Since the difference is like really low, negative 1.8 and negative 2 are really close to each other, we can be pretty sure that that is not our answer. Now, for B, based on the graph, which of the following statements are true? Let all that apply. Okay, each additional minute Carla is in the store is associated with an additional 2.2 spent. Okay, first there's part of this spend that is true, but I want you to think about the actual equation we have. So in the equation, the slope is the value that define what is happening with the y with the independent variable. So we have that for each one the x increases, the y is going to increase by 2.4. So if the x are minutes, we know that for each minute, the y is going to increase by 2.4. So this is not true because it's saying 2.2. But part B says that each additional minute in the store is associated with an additional 2.4 spent, which is actually true because 2.4 is our slope. So this is true. Now, if Carla stays for 30 minutes in the store, she will likely spend about $70. Okay, first, to do this, we are just gonna use the equation. We have y equal to 0.4x minus 1.8, and we're saying 30 minutes. So I'm going to substitute our value. Minutes are the x, so 2.4 times 30 minus 1.8, and this is going to be 48 minus 1.8. Oh, no, wait. I made a mistake. I'm sorry. 72 minus 1.8. And this is approximately, this is 70.2 point, yeah, 70.2. Just let me make sure I get it right. Yeah, 70.2. Um, Basically, if Carla stays for 30 minutes in the store, she will likely spend $7.2. And C is really close to that statement, so I could say that C is also true. While D is not true because it's saying about $64, which is not nearby, near 7.72. Now, if Carla stays for less than 5 minutes, she will likely spend no money. Okay, let's make a calculation using any number between 0 and 5. I'm just going to use 3. So, y equal 2.4 times 3 minus 1.8. So this will be 7.2 minus 1.8. And this will be 5.4. Well, here we can see that for any time she spends in the like if she spends less than 5 minutes, she's going to still spend money in the store because of the best line of fit. Also, we use values for the minutes, like for the x values, which are the minutes like 1. For example, if we substitute the x by 1, we are going to say 2.4 times 1, which is 2.4 minus 1.8, is still going to be 0.6. So even if she spends 1 minute in the store, she's likely, based on the line of it, to spend money. Therefore, this is false, and our true values statements are B and C. Okay, last page. Wow. Hello, I'm back. I'm sorry for the cut. I was just trying to do it from another way. It didn't work. So I was doing it before. Let me read this question. 49. The Scatterplot shows the relationship between average rainfall in inches and wheat crop yields in bushels per acre. I'm sorry, I don't know how to pronounce that word. Part A, which is the following is the equation for the line of best fit for the data. Now, what I would do, since the formula to actually calculate the actual line best fit is really long, and I don't I don't think it's like actually very important for the exams. I haven't even seen a question specifically about calculate the regression line. But what we do need to understand is what is a regression line, how does it work, if we can interpret the regression line, etc. So basically, what I will do is select 2 points, any 2 points that you think are basically in the middle, not too high, not too low. Um, Based on that, I will select, I will say this point right here, and I think also this point right here. Oh no, but like I think this one can be better. Yeah, and I'm going to make a line from one point to another and just continue. Wait, it didn't work. Well, you get what I mean. So suppose that the this line is actually, oops, is actually passing through those 2 points, and then like the data points are over and under the line. It's easier to use. So I will choose those 2 points, and I'm going to calculate the slope, and this will be 35, comma 102, we'll say, 15, comma 48, we'll say, 47. So okay, sorry about that. 102 minus 47 over 35 minus 15. 102 minus 47 will be 55. 35 minus 15 is 20. And when I do this division, I get 2.75. Let me actually do it. By the way, 20, 2.75. Yes, that's the answer. I can see here that the nearest slope that I see is 2.8. So I could say that this is going to be our answer. No, said all the true statements. If the annual rainfall increases, the yield of wheat business per acre, I'm sorry about that, will also increase. Um, Basically, it just means that it has a positive correlation, so if one increase, the other also increase. And as we can see here, like it's pretty positive. It's going straight upward. Well, not straight, but it's going upward diagonally. So yeah, A needs to be true. And B, if the yield with bushels per increases, the annual rainfall will also increase. Basically, I'll say also yes, because if one increases, the other does. So if we wait, I'm listening something weird here. I'll come back in one. Okay, I'm sorry, I'm back. It's just that I was listening some noise. Okay, now, as I was saying, yeah, like when you see that one is going over, the other is also going over. I know that in this case, the width is the independent variable, is the y, but either way, hmm, I think it might be a tricky question. It might be a tricky question because if you consider the actual natural world, you say, okay, the yield the wheat bushels, we know that there's a plant, and if the for any thing or for any like specific reason, the the production of that plant or that like orchard or whatever increases, it does not mean that the rain that is going to rain more, like be more rain or raining more. So I will say no based on that. But it could be a real trick question. I don't know. Then based on the line of best fit, if the annual rainfall reaches 50 inches, the yield of the wheat bushels per acre will be 125. So now let's calculate. We have our equation. We know that the rainfall says that it's 50, so I need to substitute our values. Y equal 2.8 multiplied by 50 minus 25. So y equal 2.8 it should be 140. 2.8 times 50. Yes. 140 minus 25 will equal 115. And when we come here, 125, okay, 185 is way too high. And then for this, it actually could be 125 because there's not like that much difference between one and like 155, 125. So I will say that this could be true. And then if we multiply by 60, it will be greater since it is increasing. So 2.8 times 60 times 60 is 168 minus 25 is going to be 143, which is a lot bigger than, oh, actually, that's exactly what E is saying. So what I said is that, sorry about that. Y equal 2.8 times 60 minus 25 and 2.8 times 60 as I calculated here 168 minus 25 and y equal 43 143 and that's what E is saying, so that's true. I don't know about C though because we don't get the actual value, so I don't think it actually works, but the ones that are for sure true are A and E. Now, last question. I'm sorry about all of these linear correlation questions. They're pretty weird, but it's important to understand what is happening. So, the scatter plot shows the mortgage interest rate, Y percentage, at a local band for the years 2000 to 2008. The associated residual plot is also shown in the graph. Okay, which statements are true? Select all that apply. The mortgage interest rate and time since 2000 have a weak positive linear correlation. So as you can see here, the graph is going down, so it cannot be positive, have a negative correlation because with time or like with the increase of the x value or the dependent variable is actually decreasing the other variable, so it does not have a positive linear, like a positive correlation. So A and B are now. Then the mortgage rate, interest, and time since 2000 have a weak negative linear correlation. And I would say yes, because it's going down but really slowly. If it will be something like this, I would say okay, this is like pretty negative. This is really a strong negative correlation, but this is going like slowly down. So I would say that C is true. It is a weak negative correlation. So therefore, D is not true because D is saying strong. And then as the time after 2000 increases, as the time after 2000 increases, the mortgage interest rate increases. Um, this is just saying that it is going up, that with time, like every time is going to the left, the rates are going up, which is not true as we can see in the graph. It actually decreases over time, so that's our true value because it is going down, as I said before. And that's basically it. It was faster than I was expected. I'm gonna put like a review video in the description as always, and I'm there in Discord for any question you might have. Thank you.